Today we will be talking about gradients. So I'm going to help you guys learn how to find the gradient or find the function for a gradient. And also we're going to discuss the concept of a gradient. So if you don't really care about the concept, you just want to figure out how to solve for one or how to find one, just skip ahead in this video because I'm going to be talking about the 3D Desmos example for this. And shout out to Desmos. Once again, they always have like some good examples of something. I just use these for these videos. So what is a gradient? Well, as you can tell, we have a point here. This point is approximately 1, 1, and approximately exactly 1, 1. And you can actually find the tangent line that on this graph. But this tangent line will be different depending on the direction that you are pointing this tangent line in. So as you can tell, I can spin this line around. But what does the gradient do? The gradient is a vector where its magnitude and direction indicate the magnitude of the slope and the direction of the steepest ascent. So what do I mean by the steepest ascent? Well, as you can tell right now, there's a slope on this graph. But what happens if I rotate this? Well, this slope gets smaller and smaller, right? As I rotate it more in some directions, the slope's pretty low. But let's turn on my gradient vector. This gradient vector, this red arrow here, actually points in the direction where this directional derivative or this tangent line has the greatest ascent. And if I try to get it approximately in the right area, about this much, you can tell that this will be the highest ascent, because if I rotate this in any different direction, the slope goes down. Let me try this out. Yeah, look, slope goes down here. Right, the slope of this line is less, and if I try to go in the other direction, the slope is less as well. So the gradient is just a vector that points in the direction of the steepest ascent, so where the slope has the greatest magnitude. And also, this is something that's not as important to know, but the magnitude of the gradient also determines the magnitude of the slope. So let's move on to learning how to find a gradient. How do you find the gradient? Well, the gradient is actually pretty simple to find. It's honestly not that bad. But the gradient is going to be defined as, and this is just the notation for it, an upside down triangle called either del or nabla, depending on what your teacher wants. But this is the gradient notation, and the gradient is just the f of x partial with some x point and y point paired with the y partial with some x point and y point as the inputs. So the x and y partials are functions, and you can plug in points in these functions in order to get your gradient. So let's give you an example for this. Example would be for f of xy is equal to x squared plus y squared. So how do you find the gradient for this? Well, the gradient for this would simply be the f of x partial. So we have to find the f of x partial and the f of y partial. So the f of x partial for this is 2x, and the y partial for this is 2y. And all we do is put this in sort of a parenthesis. And there you go. This is our gradient for xy. How about if we want to find the gradient in a specific point of this graph? Well, the gradient in a specific point of this graph would just require you to plug in the values of that point into both of the functions here. So let's say you have point 1, 1. Let's do 1, 3. Correct? Just plug in the values of 1 and 3, x and y respectively, into the gradient. If you plug in 1x into the gradient, so the first x partial of this gradient, so this is the x partial, this is the y partial here. Let's write these with different colors. It's the x partial, this is the y partial. If you plug in 1, 3 into the x partial, you will get just 2, because there's no y value inside of your f of x function. If you plug in 3 into as the y value in the y partial, you get 6. And you'll treat this as a vector. And this vector is your vector that in which its direction points in the directional derivative of the greatest ascent. Let's try one more. So for the function sine of xy plus x squared e to the power of y. Let's find the gradient for this. Well, the gradient is defined as the x partial and the y partial paired with the y partial. So let's find the x partial first and then the y partial. So the x partial in this case is y cosine of xy plus 2x e to the power of y. And the y partial for this would be x cosine xy plus e to the power of 2 times e to the power of y. Now, all we have to do is just put this in a pair. And this will be our gradient. So this is our function for the gradient. But remember, in order to have a gradient as a vector, you need to find the point that you want to find the gradient at, and you need to plug in those values. So let's use the point 1 and 0. So this is equal to del or nabla of x, y. So we plug in the values 1 and 0 into here. So we plug in the values of, this is x, and this is the f of x partial, and this is the y value, and this is the y partial. So we plug in 1 and 0 into here. So this is the x value, and this is the y's 0 value. This turns into 0 because no matter what's in the value of the cosine, since y is 0, you're multiplying 0 by anything, it turns into 0. How about for x e to the power of y? Well, x is 1 and y is 0. And e to the power of 0 is simply just 1. This is 2 times 1 times 1. So it's just 2. This is equal to 2. How about here? Well, for x, we have 1. And we have cosine of xy. So this is just cosine of 0. Because y is 0, no matter what the x value is, the value inside the cosine will be 0. And again, this is just 1 times e to the power of y. E to the power of y is just 1. And x to the power of 2 is just 1. So it's 1 times 1 is 1. And cosine of 0 is 1. 1 plus 1 is 2. So our gradient vector here is 2, 2. So to recap, all we did was find the partials. So we found the partials. And the next thing that we did was plug in the values of our point in the partial. So we plug things in, and whatever value we get for this gradient, so whatever value we get after plugging things in from the point that we choose to find the gradient for, we get a vector. And this vector right here finds the direction of greatest ascent for a directional derivative. So if you have any questions, put it down in the comment section.